Okay, this is chapter 5. After we finished doing chapter 4, which specifically talking about probability rules, now we have to go more in depth and speak about probability distributions. Probability distributions. Chapter 5 is designed and planned to cover this one type of probability distributions, which is discrete probability distribution. We will be discussing what does it mean by probability distribution, what does it mean by discrete, etc. And we are still in the middle of the bridge. As we said, we are crossing the bridge towards having some information about the population, because everything we have done before was about sample, and we are crossing the bridge using chapter 4, 5, 6 to jump into talking about some kind of we need some information about the population. So at the end of this video, we will be able to calculate and interpret the expected value of the discrete probability distribution. We will be able to apply binomial distribution to business problems, and we will not cover Poisson distribution today. And we should understand or recognize when to apply discrete probability distributions, because we have two types of distributions. As we said, we have two types of distributions. We cover in chapter 5 the discrete probability distributions. In chapter 6, we'll be talking about super important type of distribution. We call it continuous probability distributions. And the most common, or the hero of the continuous probability distribution, is the normal distribution. We'll be covering one distribution from the discrete and two distributions from the continuous. So before we explain what does it mean by distribution or probability distribution, we need to define excuse me, we need to define an important concept, which is, we call it random variable. Random variable. So this word, there's two words actually. I mean, this phrase contains of two words. One of them is random, the other one is variable. Random because it is random. Which one is this variable? Because it is variable. So random variable. So when the value of a variable is the outcome of a statistical experiment, again, we back to the experiment because we're doing experiments. The variable, we call it random variable. Random variable. It is the value of a variable, that value that the variable takes for the outcome of the experiment, we call it random variable. What is the probability distribution? Is the table that linking two things. Link each outcome of the experiment with what? With its probability of occurrence. It's a table, make connections between each outcome of the experiment with the probability of the occurrence of that outcome. This random variable can be discrete and can be continuous. It is discrete if it's determined by counting, discrete, number of complaints, discrete, number of TVs, discrete, we talked about discrete, and number of rings, discrete. Continuous, generally defined by measuring the time it takes for something. The time is continuous. The distance is continuous. The weight is continuous, because as we said, between every two numbers you can still find a number. Every consecutive, you feel that they are consecutive, but you still can find uncountable numbers, uncountable values between the two values. But in the discrete you can't find countable. If I, for example, said number of complaints 500, how many numbers you can find between 5 and 100 is countable. But if I tell you that the distance between the two cities, for example, 50 miles or 51 miles, so the distance between, or the how many values we can find between 50 and 51, uncountable numbers. So there's so many numbers between them. So that's why they are continuous. This is a very simple example, very nice example, to distinguish between the random variable and the probability distribution. When we toss the coin twice, this is our experiment. Now we are going to define, we are going to define the random variable. How to define the random variable? Is the variable of interest, again, the thing that you would like to study, the variable that you care about, the variable that you would like to know more about. That's why you have to define the random variable. In this example, we're going to say the random variable is going to be x, which is what? Number of heads. What does it mean? It means that if you do an experiment of tossing the coin twice, or two coins, you have two coins, you toss them, and this experiment, when you toss the two coins, you'll get results, right? Outcomes. You're going to record these outcomes. So all of the possible outcomes are these. Then I want to know, I am interested to study when we have heads. We need to count number of heads. So number of heads is going to be my random variable. So this is my random variable. So either you're going to get two heads, which is in this case we have two heads. In this case we have one head. In this case we have one head. In this case, we have 0 heads. So the values that this random variable takes is 0, 1, 2. 0, 1, 2. So this is my random variable. Now, the question is, what is the probability? The question is, what is the probability that x is going to take 0? What does this mean, by the way? It means this one, by words, it means what is the probability that, the probability, okay, when tossing 2 coins, what is the probability of getting 0 heads or no heads? No heads. This is the question. This is the meaning of that one. What is the probability of getting no heads? We have only this one. This one has no head. So we have only one outcome out of 4. So 1 out of 4. So the probability of x equals 0 is this. What if I ask you, what is the probability of x equals 1? What does this mean? It means when tossing 2 coins, what is the probability of getting 1 head? We are getting 1 head here. We are getting 1 head here. So how many times did we get 1 head from 2 different outcomes? So we have 2 out of 4. So the answer is 2 over 4. So the answer here is 2 over 4, which is half. If I ask you what is the probability of x equals 2, again, when tossing 2 coins, what is the probability of getting 2 heads? We are getting 2 heads only in one occasion, which is here, right? Which is where? Which is just here. It's 1 occasion out of 4 occasions, 1 outcome out of 4, right? So the whole table now, we studied the behavior of this random variable, number of heads. So this is the probability distribution of that random variable, right? And this is very important. We're going to talk about this in chapters 7 and 8. When we do more, when we go in depth more, we're going to learn more, okay? Also, we can do the cumulative probability. What is it? It's the probability that the value of the random variable within a specific range. Like what? When we use the words, the probability for at most 1 head. And we can use the table again to compute the cumulative probability distribution. So this is the random variable. We use the same example, number of heads 0, 1, 2. The probability distribution, as I did in the previous slide, I said the probability of x equals 0 is what? The probability of x equals 1 is what? Why do I have capital letter, small letter? Just to distinguish, okay? Capital letter, just to make, sure that we have different things. Just the capital X equals little x. So the probability of x equals 2, it is this, right? And now, if I ask you a question, what is the probability of x less than or equal to 0? What does it mean? It means, this is very important. Now, these are important notations we need to understand and learn. What does it mean by this? It means when tossing 2 coins, what is the probability that we are going to get 0 head or less than 0 heads? The minimum thing is 0. So how many times are you going to get 0 or less heads? Actually, 1 time only, 1 out of 4. The other one, what is the probability that x is going to be less than or equal to 1? What does it mean by this? It means that when tossing 2 coins, what is the chance that you are going to get 1 head or less than 1 head? What does it mean by 1 head or less than 1 head? We have, the question says 1 head and or less than 1 head, which is 0. So 1 head or 0 heads. So if you go back, which one we get 1 head? This one 1 head, this one 1 head, this one 0 heads. So we have 3 out of 4. So we have 3 out of 4. So the chance of getting at most 1 head, that means the chance of getting, this one actually can be written, look at that one. This one can be written as what? Equals the probability of getting 1 head plus the probability of getting 0 heads. What is the probability of getting 1 head is actually 2 over 4. What's the chance of getting 0 head is 1 over 4. So the total is going to be 3 over 4. The last one is, what is the probability of getting less than or at most 2 heads? Or less than or equal to 2 heads. Actually, we will be getting, the most number of heads we're going to get is 2, so the answer is going to be 1, automatically 1. Because what does it mean by this? This means that we are looking for the number of heads. It could be 2, or 1, or 0. What is the chance that we're going to get 2 heads? 1 out of 4. What's the chance that we're going to get 1 head? 2 out of 4. What's the chance that we're going to get 1 head? 0 head, 1 out of 4. So the answer is 4 over 4, which is 1. So in other words, the question says, what's the chance that the maximum number of heads you're going to get is 2? The chance is 100% because I mean, every time you're going to get either 0 or 1 or 2 heads. That's it, right? So this is the cumulative probability distribution. And as we said, because the random variable we used is discrete variable. This is discrete variable. It takes values 0, 1, 2. We don't have values like 0.1, 0.2. I mean, we don't have continuous values. That's why we call it discrete probability distribution, because this random variable is a discrete variable. So this table, we call it discrete probability distribution. Now, because we have a distribution, we can get the mean value, the expected value. We call it, when we talk about probability distributions, we speak about expected value, which is kind of equivalent to the mean, kind of, right? So we find the mean of the probability distributions. What is the mean of the probability distribution? Is the expected value. How do we find it? What is the notation of that? It's E of x equals the summation of x times P of x. E of x is the expected value of x. X is the values that the random variable takes. The probability P of x is the probability of the random variable that taken on the value x. We're going to have an example. The other thing is the standard deviation of the probability distribution. We still can find the standard deviation, right? How to calculate the standard deviation? Using this formula. I will be using the Excel, the table. I mean, we will be constructing this in Excel. So I'm going to record another video to have an example of how to find the standard deviation, but maybe we can do just right now one by hand quickly here. What is the expected value for this? The expected value of x. We have a random variable. We have the same example, right? The random variable is x, which is number of heads, 0, 1, 2. We have the probability distribution. How to find the expected value? You just multiply. We create another column. I just multiply x times P of x. Multiply 0 times 4th is 0. 1 times 2/4, 2/4. 2 times 1/4 is just half, or 2/4. Right? Then we find the sum. So the sum of these is my expected value. So 0 plus, which is 1. The expected value for this random variable is 1. Is kind of the mean. The mean of that random variable is going to be 1. What does it mean? The mean of getting, the number of heads that we're going to get is kind of 1, right? 1 head. When you do the experiment, if you do it like 100 times or something, the mean, the average of these, you're going to get 1 head. You're going to see 1 head when you do the tossing the coin, 2 coins. Standard deviation, it's a long way of calculating this, so we're going to do it on Excel. So I'm going to move after I finish from this one to Excel. So let me pause here because we're going to do the Excel part for this problem and maybe other problem. After that, we'll be talking about one important type of discrete probability distribution, which is binomial distribution.